All right, guys, we're going to go ahead and come back together here. Yeah, so good job on the quiz there. Just make sure that's working. Looks good. I'll answer a couple. There were two questions that more than one team missed, so I'll kind of go over those briefly. Those were questions 1 and 8. So question 1, we're actually going to dive into with the first couple of questions on these right here. Not quite there, but when we get to here, we'll talk about insulin and glucagon and all the different things that control blood sugar. So I won't really go into that one. But then question number 8 was the one that had to do with which of these hormones causes more water retention, but then also causes more sodium retention and potassium excretion. Okay, so the best way to think about it is ADH is primarily concerned with causing you to retain more water. Okay, so it does that first, and then because of that, more sodium goes too, but it directly acts on water, whereas aldosterone directly acts on sodium and potassium, and then because of that, water follows it. Okay, but that's kind of the best way to think about it is aldosterone, sodium, ADH, water. But as far as their direct actions go, but then water or sodium will also kind of eventually follow the other ones. But yeah, so with that question, the only one that does both sodium retention, potassium excretion, and then because of that, water retention, that one's aldosterone that does that one. So yeah, any other questions on those that you wanted me to address? Okay. All right, so this first set of activities will be different than the next ones that we do. This one is just some multiple choice questions we'll do for the rest of this class period. And so what we'll do is I'll have you do a couple of them, talk through them with your teams, and then we'll come back together and I'll have you use those little whiteboards to write your answers on them. Okay, and then at the end of the time, we'll just have you hold them up, and then we'll move on to the next couple. Okay, so let's get started here. So let's do these first two questions. We've got 2 on catecholamines here. So go ahead, talk about these first 2, and then we'll come back together and chat. Go ahead. Yeah, so it's just the next PowerPoint after the ones you studied.
No, it's just
So yeah, if you want to just put both the answers on the board, so you can just do like 1 and 2 or something for these two questions. Do this one and the next one as well. Doesn't work. Try this one. That one work?
Yeah.
Okay. Yeah, I'll give you a little more time to finish talking about that second one as well. There's one more question now. So just talk about this one too. Just 2 on the catecholamine. Yeah. Not exactly correct, but it's cute. All right, looks like most of you are done with both of these. So go ahead and hold those boards up. I want to see what you said. Okay, so we got 5 out of 6 teams saying DC, and then 1 team saying DE. Okay, so let's look at this one first. Okay, so Everybody said D, so epinephrine and norepinephrine. Okay, yeah, that's correct. I'll circle it. There we go. Okay, and then this one, are catecholamines a part of the endocrine system or the nervous system? Let's kind of go back to how we define those things. So when the two things that we think about when we are like categorizing chemical messengers in the body are what is it that releases that chemical, and then what does it release it into? Okay, so what would be our options for things that would release chemical messengers in the body? What would be something that would release a chemical messenger? A gland, there we go. That's option number one. What else could release things into the body to communicate with something else? There you go. Yep, glands and neurons, right? So those are our two options, okay? And then the two options for where it's released. Glands typically release where? Into what part of our body? The blood, yeah, typically release in the blood. Neurons typically release in that little space between the neuron and whatever the target tissue is, right? So into a synaptic cleft, into neuromuscular junction, whatever it might be, okay? So the definition of a hormone is it's released by a gland into the blood. That's just the definition of a hormone, okay? Definition of a neurotransmitter is it's released by a neuron into a synaptic cleft, okay? So what is it that releases these catecholamines? What kind of tissue? Neuron, okay? It's a part of a gland, right? Yeah, this one's kind of tricky, right? That's why I have these questions. So what is the gland called that releases these guys? Let me say it besides John. Huh? Adrenal gland, okay. And the adrenal gland's kind of funky because it has the adrenal cortex, which is the outside, which is part of our endocrine system. But then it has the adrenal medulla on the inside, which is all neurons. Okay, so it is part of the nervous system. Okay, so we have neurons releasing this. So far we're fitting the definition of a neurotransmitter. But what do these things get released into? The blood. Yeah, so they're kind of a crossover. They're between the two, right? And so a lot of you said both. They're neurotransmitters and hormones. Some of you said this. And yeah, they can't really be both. So this would probably be the better answer. So neuroendocrine, right? So they're released by neurons into the blood. And that's considered neuroendocrine. We have lots of neuroendocrine glands in our body. The adrenal medulla is one of them. We also have the pituitary gland, right? The posterior pituitary gland, that's neurons, that releases into the blood, okay? We have the pineal gland, which is like that. The hypothalamus is like that. A lot of different glands are that way. They're made of neurons, but they release into the blood. So they're kind of somewhere between neurotransmitter and hormone. Okay, questions on any of that? And then it's probably good just to touch back on the definition of, or just kind of the breakdown of the sympathetic nervous system too, right? So when we look at the autonomic nervous system, which includes both parasympathetic and sympathetic, we've always got a two neuron chain for the most part. You guys remember that? The preganglionic neuron and then the postganglionic neuron, right? And so we got that on both sympathetic and parasympathetic. And then it's always that postganglionic neuron that releases something right at the target tissue and causes the action. But on the sympathetic side, we have this second way of the sympathetic nervous system doing it, which is the preganglionic neurons come to the adrenal medulla. And then instead of having a postganglionic neuron, it's the adrenal medulla that releases hormone or releases those chemicals into the blood. Right. So this is part of the sympathetic nervous system. It's just this kind of branch of it that uses the blood instead of a postganglionic neuron. Okay. Questions on any of that? Because we'll keep coming back to this. Obviously, the way that catecholamines interact with us during exercise is absolutely crucial for exercise. So this will be something we talk about all semester. So, okay. All right, so take a sec and work through this question here. And yeah, and then we'll come back. And you guys can kind of look at the next slide too for some help if you want. That slide shows all the different hormones and what they do. All right, go ahead and hold those up if you're ready. Okay, we're pretty well split between C and D. Okay, so what's the difference between C and D? Let's look. They're pretty similar except for this one. No change in growth hormone. Okay. And yeah, does this one show growth hormone? It doesn't show growth hormone. Okay. Yeah. So so there is growth hormone does help us with blood glucose control. It's not the primary regulator of it for sure, but it definitely does, especially with longer term, like longer bouts of exercise, getting over an hour and stuff. We'll see that help us, and we'll talk about exactly how it helps us in a sec. But yeah, this one, so decrease insulin, increase glucagon, increase cortisol, increase growth hormone, increase epinephrine, increase norepinephrine. Okay, so this is incredibly complex, the way that the endocrine system controls blood glucose. And it's incredibly important though too, because we go from burning maybe somewhere around 1 calorie per minute up to burning sometimes 20 calories per minute, right? In a matter of about sometimes 30 to 60 seconds, we can change our metabolism that much, that rapidly, right? And most of that's getting pulled right out of our blood, right? So the body has to have drastic measures and multiple measures to maintain blood sugar, right? And so when you look at this graph, what stands out to me is the glucose line, right? There's all those other hormone lines that are kind of crazy, and I don't expect you to know like timing or things like that of those, but the amazing part is the glucose almost never changes for 3 hours of exercise, right? That's incredible, right? We can maintain our blood glucose almost perfectly when we're just draining energy out of our blood, right? Because of the way all these different hormones act to do that. Okay, any questions on that? All right, let's go ahead and do this one then. Go ahead, talk about this one, vote on this one.
Oh, sorry.
All right, hold those up if you're ready. This is going to be a choose all that applies, so you can choose more than one. This was the one in the notes that some of you were stressing about last night because you're like, it's not in the book. That's why I didn't put it on the quiz though, too. All right, go ahead and just take your vote. If you're not sure, hold your answers up there. You can see, I like that. Okay, get some peer pressure in the back. Okay, yeah, so pretty much everybody's saying A and E. We had one, maybe C over here. Okay, so GLUT4 is a transport protein. It's part of a family of transport proteins that allow glucose into cells. GLUT4 is the one that's stimulated by insulin. So insulin binds to the surface of our cells, leads to this whole chain of events. And then there's all these little GLUT4 proteins typically waiting inside of a vesicle inside of our cells to be stimulated, to go to the surface and open up so we can let glucose in, okay? And that's what GLUT4 is. So it's directly stimulated by insulin, but it's also directly stimulated by exercise, completely independent of insulin. Okay, so the maybe C one was C is definitely correct there too. Okay, so insulin binding to the outside of a cell leads to GLUT4 coming to the surface of that cell. True. Exercise without the help of the endocrine system also leads to GLUT4 coming to the surface of the cell. And then E, during exercise, insulin levels must decrease so we don't have an unsafe drop in blood glucose. So A, C, and E are all correct. And this is why, I don't know if any of you have ever experienced this, but if you eat a high carbohydrate meal, especially if it's a high, like refined carbohydrate meal that gets into your bloodstream quickly, and then you immediately start exercising, you all of a sudden have to run to go catch something or do something right after you've eaten. Sometimes you can pass out, or you can get kind of lightheaded because your blood sugar drops so rapidly because you have a big insulin spike from the meal. And then you also have a GLUT4 increase from the exercise at the same time. So you kind of get double the amount of GLUT4 on your cells that you normally would. And a lot of that blood sugar just gets drained rapidly. And so, yeah, that's kind of part of the reason that could happen. Oops, sorry. That's not what I want to do. There we go. This is very important for people with type 2 diabetes, right? Because their insulin mechanism isn't working. Right, so the insulin goes and binds to the cell, but it doesn't. The chain of events isn't working properly, so they don't get as much GLUT4 going to the surface of the cell. But exercise bypasses that whole route, and it has a whole separate way to get GLUT4 to come to the surface of the cell. And so exercise is so crucial for type 2 diabetics to control their blood sugar because of this, right? And so very, very helpful. And the effects of this can last for 3 days. One bout of exercise in type 2 diabetics can last for their insulin sensitivity or just their GLUT4 levels rise for 3 days. So even just one bout of exercise a week, if that's all somebody can get in, that's way better than nothing if you've got type 2 diabetes for blood sugar control. Okay, any other questions on those? All right, let's do this one. Who's saying it this time? Penguin?
No,
Who is it? Oh, you're John Guy. Nice. I just thought it was a bill at first. Sorry. Okay. You don't look like a penguin guy, but that's it for a second. Yeah, you're welcome. All right, go ahead and hold something up here. Come to an answer together. What do you guys think? Hold them up. Kai says C. Okay, either C or B for the most part. So some people are saying B, both lead to more fat breakdown, so it can be turned into glucose. Both lead to more fat breakdown, so glucose can be spared. Okay, so kind of the same idea here. Lipolysis is the process. Right, that means breakdown of fat. Okay, so we can take some of that stored fat, put it into the blood as triglycerides. Those triglycerides can be burnt through that process we looked at just briefly in metabolism, right? So there's different ways to help our blood sugar. One is to pump more blood sugar into the blood, which is the other hormones we were talking about, but this one doesn't do that. It actually spares some of that glucose so we can use other fuels, right? That's how these two help us, right? And so we see, yeah, so C is the correct answer. Definitely your body can turn fat into glucose, but it doesn't happen super rapidly. It takes a little while. So it's not something that we're doing like a lot during exercise that would benefit us during that bout of exercise. So we're making more fat available to be burnt. So then we can decrease the carb burning a little bit and spare some of that glucose. Okay. What else does cortisol cause besides fat breakdown? Lots of stuff, right? But what would be something related to metabolism? What else does it cause to be broken down? Protein, yeah, it's a catabolic hormone for sure. So it causes protein breakdown. So we can get some amino acid availability too with that, which also helps with blood glucose control. It's also major anti-inflammatory, right? A host of other effects that cortisol does too. Okay, questions on any of those? Okay, this one. All right, if you're ready, go ahead and put that on there. Hold it up. All right, hold them up if you haven't yet. I think that's an A, but I'm not sure. Okay, you put like all the letters on top of each other. Gotcha. All right, so it looks like pretty much everybody put A. So ADH release is stimulated by hyperosmotic blood. So what's a way to get hyperosmotic blood? How do we end up with hyperosmotic blood? What does that mean as far as like the balance of salt versus water? More salt, less water, more water, less salt? Which one? Hyperosmotic would be what? A lot of what? A lot of salt, not much water. That's just being dehydrated, right? Yeah. So when we dehydrate ourselves, we lose more water than we do salt. Sure, we lose some salt too, but we lose more water. So hyperosmotic blood would be yeah, so obviously exercise is directly connected to that. And then renin release is stimulated by decreased blood flow to the kidneys. Okay. All right. So whenever we talk about these hormones, it's always important to think about what's the stimulus for their release, where do they get released from, what's their action, those kind of things, and then maybe some negative feedback too, what slows down the release of it. Right? Okay, so this system here, the renin, angiotensin, aldosterone system, talk through that. All right, go ahead and hold it up. Okay, I see some C's and some D's, mostly D's. Okay, so D says kidneys release renin. Renin converts angiotensinogen into angiotensin 1, and then ACE converts, angiotensin 1 into angiotensin 2. Okay, that's the correct pathway. Let's talk a little bit more about what some of those things are and where they come from. So angiotensinogen, what makes that? What organ in our body would make that for us? The liver, good. Yeah, so the liver makes that. Okay. And it's just one of our plasma proteins, right? That's kind of the cool thing about plasma proteins is we have a bunch of proteins that are just in our blood, just waiting to become activated. Like most of our blood clotting system is that way, right? It's just kind of all these different proteins floating around. If they happen to interact with the right enzyme, our blood can turn into a solid, right? Just like in a matter of seconds, right? Same thing with angiotensinogen. It's just always there. It just has to interact with renin. If it does, then it starts this whole chain of events, which is our primary regulator of our blood pressure and our water and sodium balance, right? So it's just always floating around. If it happens to interact with renin, because renin was stimulated to be released from the kidneys, then renin's going to turn it into angiotensin 1. And then ACE is, I'll call it angiotensin converting enzyme. We find it on a bunch of different endothelial cells all around the body, but primarily in the lungs is where most of this gets converted. It just kind of sits on the membranes of endothelial cells, which line our blood vessels, right? And so when after it turns into angiotensin 1, then it's going to interact with that enzyme in the lungs. The lungs, why the lungs? Well, it's because that's where all of our blood goes through, right? All of our blood goes through the lungs at some point. In a matter of a couple of minutes, all of our blood has gone through the lungs because it's got to get filled up with oxygen, right? So it's a good place to do something like this in the body. Yeah, so that ACE enzyme turns it into angiotensin 2. And angiotensin 2 is really the hormone, the one that's going to have all the actions, right? A couple things about this. ACE is a drug target, right? If you've heard of ACE inhibitors, right? Like lisinopril, a very common one, most popular blood pressure drug out there, because of the next slide, all the effects that angiotensin 2 has, right? So if we can block the formation of angiotensin 2, then our blood pressure goes down for sure. And then what else are we going to say about that? Oh yeah, with the way that COVID enters human cells is through a process that involves this as well. It goes through an enzyme. There's a few other different pathways that angiotensin 1 can take. After it goes to angiotensin 2, then it can turn it all the way down to like angiotensin 7 that has some cardioprotective effects. There's a hormone bound to an enzyme bound to our lung cells and a lot of our cells across the body that is the primary entry point for those spike proteins on COVID. And it's called ACE3 or something. There's some enzyme name, but it's all in the same family of enzymes. And that's how it enters cells. So, okay. And then, yeah, last one here. Go ahead and talk through this one. All right, so put all that are true on there. Hold it up when you're ready. All right, hold them up. Saw most of them. Yeah, good. So most people are saying B and C. Okay, so it leads to ADH release. So it goes directly to our posterior pituitary, causes ADH to be released. It's also a direct vasoconstrictor too, right? So it actually binds to our blood vessels and causes vasoconstriction. Okay, it also goes to our adrenal cortex, causes aldosterone release. Okay, and then it also just activates our sympathetic nervous system. What it does actually increases the sensitivity of all of our adrenergic receptors by just the same amount of epinephrine binding to that, causes a greater response. And that's kind of the way that that works. And so with the ADH release, obviously this one is increasing water retention. All right, with the aldosterone release, this one's increasing sodium retention. All right, with this one's increasing blood pressure. All right, this one's also increasing blood pressure. Okay, so we kind of have this holistic effect on our blood pressure and on our fluid and salt control with this one hormone, right? It kind of does it all. Right? So, all right, any questions on any of those? All right, guys, have a great rest of your day. We'll move into the cardiovascular system on Wednesday. See you then.